Okay, I think we're good on YouTube. Welcome everyone. I think we should be live on LinkedIn too. Let me just log in and just make sure everything looks good. All right. Welcome if you're joining us from LinkedIn. Great to have you. I'm just copying over the link. Okay. Great, just sharing it with my fellow attendees so they can answer your questions on LinkedIn. All right, well, it's been a few minutes, so I'd love to get started and leave plenty of time for our Professor Lightning Talks. So I just have a few intro slides, and then I'll pass it over to our speakers. All right, so welcome everyone. Thanks so much for joining us. This is part of the Data plus AI online meetup group, and this is a Databricks University Alliance program Lightning Talk series. So each of these professors is part of our University Alliance program, and we also have that the person who leads that program here today too. So we have Marlon, Suhong, and Jay.
Hi, everyone.
So just a quick reminder, this is part of the Data plus AI online meetup group, and the recording will be available on our YouTube channel. So I know we have some folks joining us from LinkedIn. We have some folks joining us from YouTube. So feel free to drop your questions in there while the speakers are presenting, and we'll get to as many questions as we can. I just wanted to do a quick call out. We are in season 2 of Data Bro. So that is with Denny Lee and Brooke Winnick. And I invite you to check that out. So this season is all about machine learning from research to production. So I believe there's 8 or 9 episodes and some really amazing speakers there. So I invite you to check that out and get that available wherever you get your podcasts from. And then also too, we have a guest blog program. So if any of you are interested in blogging, maybe you have a topic or you have a use case or a project that you're interested in sharing, I invite you to reach out to me. Or you can also click on that link. I'll share it in the chat spaces. And there's some more details on the page, on the program page, and a form to fill out. So you can submit your idea and we'll get back to you and see if it makes sense to publish it on our blog, our Databricks blog. And so without further ado, I'd like to pass it over to Rob Reed. He's the program manager for the University Alliance program.
Thanks, Karen, and thanks, Marlon, Suhong, and Jay. The less I talk, the better. I'm just so thankful that I have such a strong community of faculty who are teaching analytics and are using Databricks. And I think the purpose of this talk is just to foster communication amongst faculty so that we can all learn from each other. And I think with that, I will turn it over to Marlon, who may have been walking along the beach this morning, but was not surfing. So Marlon, take it away.
Thank you, Rob. Thank you so much. Hi, everyone. I'm Marlon, professor from UCL. In this session, I'm going to speak about some big data courses in analytics we're conducting. We started as a new format last year. The Databricks Alliance come up, and then a little bit about me. Rob, can I start? How?
Yes, please. Take over slides, whatever you would like. And I just want to also point out that Marlon may be the most professional among us because he has a real microphone and you're coming in loud and clear. So thank you, sir.
Yes, you, audio and video sound better than both of us, Rob.
Is it okay? My slides?
It looks good.
Yeah. So we have a main course here in UCL called Big Data and Analytics. So A little bit about me. I'm solutions architect at Banestas. It's a state bank here in Brazil. I'm from Brazil. Vitória is the capital of the state of Espírito Santo. So I'm solutions architect in the main lines of big data, analytics, and projects involving data science and machine learning. Also professor at UCL, mainly at IT courses. CEO of LabMeIn. It is a new edtech for project-based research. So it is involved with the teaching and learning, mainly online. And you can check my LinkedIn here. This is the link if you want. Course objectives, of course, it is provide the data and engineering and architecting, data architecting skills for IT students. It is important to describe that it is not statistical, not data analytics purely. It is IT students which brings with the web development, mobile development. So the core is programming and data and SQL. So the main objective is also solve problems using data tools and platforms. These ecosystems we've grew every time better. Understand and formulate solutions for business problems. So we have a market here, we have a strong marketing and resources business-based problems here in Brazil. So we have to give this background. And develop analytical skills and data manipulation, because there's a lot of tools, but how to solve it analytically is a main challenge, we think. About the course is information system, bachelor degree, the IT core. So we focus on data engineering, such as ETL, transformation, feature engineering, cluster configuration, and data pipelines, and all the programming it comes from, right? And some additional data viz techniques and approaches we use in Power BI. This is new in our discipline today. We using to plug in the Databricks and consume it, some vision, some panels, some dashboards, some APIs to consume at the marketing shared tools like Tableau, like Power BI. Our guidelines, our main guidelines is project-based approach. This is a very important approach because the students only can construct their knowledge if he is motivated, if he is interested, right? So we have some practical exams with submissions. We can test this knowledge. Evaluation by final results, we can check the tables he has done, the values, it comes up. Our dashboards, you can compare the results, you can compare the discipline which done with dashboards. We have no auto graders yet, sorry. It's a difficult part yet, but we are thinking about it. Our syllabus, it starts here, introduction to big data, 90 hours total, the discipline. We have 34 big data introduction, and then we come with big data technology, Hadoop, Spark, Hive, Parquet, 10 hours. Data engineering, it is the hard part of the discipline. Data engineering techniques, 40 hours. And then we have also for exams and case practice in 10 hours, because we have to evaluate these constructions, right? Our main projects under the discipline, main concept start with customer segmentation. We have clustering, it's our main concern. RFM, recency frequency monetary, is an interesting concept. Data analysis in RFM is very important. So then we have the business 360 with Power BI integrations, because we can consume it at those tools. Our resource starts with AWS credits and retire to show our demos and our concepts on Athena and MR and Spark and Docker and so on. And then we go to our Databricks credits. Now we have our own platform on AWS. It is deployed. It is new for this course, this semester. So we are going to use our own platform. And we have GitHub for support for exams and projects, and the students to upload their own portfolio. So this is important. Why Databricks? First, it is an end-to-end platform aligned to the marketing academy. We can use, there's a huge community support. There's a lot of people working with it, full Spark, full Python, SQL support, not limited as Jupyter like, single language, only language is not very interesting. So this is very important to us. My perceptions, so Databricks platform provided better student motivations. It is incredibly increasing because we have shareable results. We have students creating their own portfolios. This is very important. So I noted a deep understanding of data problem solutions instead of just using some tool. Oh, let's use this tool and this and this and this. But what is the understanding you catch up from everything? I perceived a very growth pattern in here. So fast job skills is important for hiring and retention. Some students relate improvement in their careers after the course. They are also working, and then due with these skills, it go to the data analytics area of the enterprise. I noted this was related by some students. So our main concerns for this course is, first, develop students' background. We have to figure out SQL, stats, programming. Let's keep that. Our cases, our data, our instruction must be applicable and replicable. The students can adopt and adapt these cases for the market, for your own interests. It is important. And the whole context problems, full solutions, not only part of something or some concept, not as a quiz. This is important also. So finally, our class format this semester is fully presential, of course, following our COVID-19 protocols. It is important. 3 times a week, 7.5 hours per week. We have some mixture of lab and classrooms. And we have also our learning environment called EASL. This is the link we're going to use for support of our class. So yes, it's presential using mask and social distancing, but it's presential also. Last semester wasn't. So where are we going to, sorry. Where are we going to go? Now, where do we go? First, our further projects. Our main further projects is to build an UCL data lake with public and anonymized internal data for academic research and projects. So we have to establish an infrastructure to allow students help and work and collaborate under certain data. Mainly focus on educational data. So we're going to put there everything there. And start to build in public data sets for community and provide long-term projects, courses projects, not only inside this course, not only in this box. We're going to move this outside in another course, another disciplines, another graduate courses. This is an example. We built this data set, is available Kaggle 2 years ago, our first trial to move the data from our learning environment in order to share this data set with the community. So with the data lake provided by Databricks, we're going to amplify these constructions, these buildings. And so many thanks. This is my email. You can contact me. We can talk about our lesson, our teaching, our learning. So thank you so much.
Thanks, Marlon.
Thank you, Marlon. That was awesome.
Thank you.
So I'm just checking if there's any questions. Phil, does anybody have any questions for Marlon? Don't see any on Zoom. Let me just go check LinkedIn just in case. Sometimes my LinkedIn is slow a little bit. No, I think we're great. And Marlon, there's a few comments on LinkedIn saying great presentation. Well, great. Well, if anybody does have any questions, I did just put his email address since he added his slides. I shared that in the chat, so feel free to reach out to him. And then I guess with that, next up is Sue Hong. If you're ready to go, take it away, please.
So everyone, welcome. And so today I'm going to share with you my experience using Databricks into my teaching and research. So this is my what I'm going to talk about, a little bit about my background, how I have used Databricks in big data analytic course, and how I incorporate into student research projects, and future plan, and some open up for questions. So I have been working at Bryant for 20 years. So I have taught courses in database, NoSQL database, SAP, data warehouse, big data analytics, and business analytic courses. My research interests mainly focus on the social media, Twitter analytics, IoT, adoption and implementation for IT innovation. So in 2017, we launched an undergraduate data science major. So currently it has become a very popular major on campus. So, and one of the core courses is big data analytics. So this is a course I'm going to talk about because I have incorporated Databricks into this course. So I just give you some little background how I have used Databricks, my evolution. So the first time, 3 years ago, I taught this course. At that time, I did not know Databricks. I'm really sorry, I forgot to share my slides. So can you see it now?
Yeah, it's okay. We see them now.
Okay, so yeah, I'm just talking about the first time I taught a big data analytic course. At that time, I did not know Databricks. So some technology I have used, I have used the Cloudera Quick Start when talking about Hadoop, Pig, Hive, Apache Flume for streaming. I also have used the Teradata Aster because they also have in the Aster, you can also do some map reduced analytic, you can do the link analysis. So students needed to install software on their laptop. So the main challenge I was facing at that time is there's a lot of troubleshooting. A student always has a problem to install Cloudera Quick Start because this is a huge program and need a lot of intensive configuration. And the student laptop has limited power. So sometimes when they run certain applications very slow. So I feel I spend more time in helping students debugging program than they are learning actual course content. So, and then I think, so they basically, I believe one of our alumni who graduated working for Microsoft, who showed me the Databricks Community Edition. So the second time I taught this course, I began to incorporate the Databricks Community Edition, but I did not full transfer to this platform yet. So again, I have used the Cloudera Quick Start and I still teach Pig Hive. And then because Cloudera Quick Start cannot process the big data set, so I introduced AWS EMR. This is a web services, and a student can run the a large data set on their map reduce platform. And then so the challenge teaching in this way is the student still needed to install Cloudera Quick Start. And then also some students are struggling to run code using EMR. So the first student, they need to submit their credit card to get the credit from AWS. Sometimes it takes a long time for them to apply for credit, get approval. And then, so for the internal data community edition, I believe it's a great platform to learn various function application. And I believe my students love the Databricks. And then the only drawback, I think maybe not a problem just because the Databricks, if we run the community edition, it's a single server. We want to be able to run a big data set. Like if you have a millions data set, it will have a problem running community edition. So, and then, so the third time last year, when I taught the same course, and luckily I got the credit from Rob from Databricks University Alliances. So I was able to use Enterprise Databricks. In this way, and the student was able to run a big data set on a cluster. So I have moved all the course content right now totally running on Databricks. So this is all the major content I introduced. I still started with the big data processing architecture, Spark SQL, data frame, streaming, and some machine learning model in MLib. Also has a big data analytic project. So this is a layout of this course. So how I use the Databricks, I started like I have a student create their account in Databricks Community Edition. I think this platform is good enough for them to learn their function. So again, they complete all their individual assignment using a small data set. My definition of a small data set is less than 1 million. And then for the student project, like enterprise, so I have you, I create like they use Enterprise Databricks for their project, because for the project, usually we have a collaboration with a few company, and then we got the real world data set, real world business problem to use in this course. So last time, and then a student got the 2 real world data set from 2 companies. And then, so each data set has over 5 million records. So that basically, again, if we are running like a machine learning hyperparameter tuning, that would be very slow if we use a Databricks Community Edition. So the student team, they did all their like hyperparameter tuning using Enterprise Databricks. And then because they're running hundreds of models, like tuning hundreds of models, so sometimes students were telling me to take several hours. They just have the class like running and then wait for the results. So how I set up this class configuration is because I have a 30 students, so I created 2 clusters. I assign about 5 students in each cluster. And then because there's some library needed for their project, so I install the library to the cluster. And then the student can start, terminate a cluster, but they're not allowed to create a cluster. I don't want a student create like 20 nodes. So, and then I'm going to use the all my credit. I want to be able to like sustain to the end of the semester. So they can start, terminate, but they're not allowed to create a cluster. And then I put my files in the AWS S3 storage. I mounted this directly to the Databricks. So for students, are just accessing a virtual folder. Very simple command, and then they can access all the data, and they can run the analysis. So, and this has been successful. These 2 projects are highly valued by companies. They are very happy with the results the student produced. I think without using the Enterprise Databricks, that would be impossible. So some advantage, I say some improvement compared with using other platform is for students, because it's cloud-based, no need for them to install any software. They don't need like use a credit card and they need to submit their information. Some students are not comfortable doing that. When they use AWS, they need to apply for credit. They need to have a credit card. They need to first apply a credit card. And then how they use a cluster is just a click of a button. They go to that link, they say start a cluster within 2 minutes, and then they have access to the powerful platform. So, and this is a course I was able to incorporate a more advanced topic. because in the past, I spent half of the time trying to help a student like debug installation problem, they have a connection problem. So I think this is a good sign. So another thing I want to talk about, I also have used Enterprise Databricks in the student research project. So the project currently I'm working on is looking at the COVID-19 tweets. I have been like collecting the tweets since March last year when the pandemic started. Today I'm still collecting. So if you look at the number here, currently I have about 673 terabytes raw tweets stored in S3 storage. And then I just look at the tweets I collected from last March until May this year. Do you know how many? I have 1.099 billion tweets. So first I want to ask you, can you estimate how long does it take to count 1 billion record in Databricks? So I just did this yesterday. So you look at data yesterday, it takes less than 2 minutes. So even I'm not using, like maybe I do not have a 20 nodes, basically because my class is, the class I created is between 2 and 8 tweets. 2 and 8 nodes. So because the Databricks can automatically adjust. If you need more nodes, it's going to automatically increase number of the nodes. So again, there are another, I just did some, oh, sorry. I also want to show you another, just very basic statistics. I'm just doing a very simple pass block code to say I want to know number of tweets by month and by year. So if you look at when the pandemic started, we have even like half month, we have 160 million tweets in COVID-19. And then it has decreased. And then starting this year with lots of people talking about that COVID-19 Delta variant. So you see the number of tweets has increased a little, but how long it take to run, just do a group by, do a count, is like just 1 minute with 1.009 tweets, billion tweets. So I think this say the power of this platform. Even for the data set like that, it takes like a minute to do some basic calculation. So, and then because I have this huge amount of data set, as you know, it's impossible to run in a single machine, maybe using Python or R. And Enterprise Databricks provide a perfect platform to analyzing such data set. So, and then because the COVID-19 include such like there's a variety of subtopic we can further explore. So, and then starting last year, this student has been working with me analyzing this data set. So there's 3 formats. It can be an independent study. It can be like for the honor student, it can be honor thesis. And then during the summer, it can be a summer research project. So, and what I did is I create a separate cluster. I call my research cluster. So again, I just like assign student to this cluster. So I separate my research cluster with the classroom cluster. So again, so basically I just want to show you some of the topic my students are exploring. The first one, like during this past winter, there's one student working with me. They're looking at like the presidential candidate influence on sentiment toward the COVID-19 protocol. What does this mean? They're looking at for the tweets, they look at whether they favor Trump or Biden. They call the political leaning. And they want to see whether the political leaning has an impact on their sentiment toward the COVID-19 protocol, like social distancing, mask wearing, or like hands washing. So the results basically, if they like people like they talk favorably about Biden, they're more acceptable to this COVID-19 protocol, like with wearing mask or social distancing. For the people like who talk Trump like most favorably, they have less positive like sentiment in related COVID-19 protocol. So, and then there are 2 students that are working on their own thesis. I think this is a very important topic. People talking about COVID-19 create lots of worry, maybe like a mental problem. So the one student are specifically looking at the tweets related to like a mental health. And then another student is they are looking at how we can identify misinformation about COVID-19, like using Twitter data. So there's two students currently, like during this summer, what they're working is they just look at how the mask wearing are talked across the states in the United States. Another one are looking at the psychological impact of COVID-19 pandemic. They're looking at 3 locations, Brazil, India, and the United States. Because for some Twitter account, for the user profile, some people, like they have location, they identify the location. Not all the people doing this, but we have 1 billion tweets. We don't need like a whole population. We have enough tweets be able to do some country comparison. Okay, so I think this is what I want to discuss. This is just some results 2 students are doing. They're looking at sentiment by month, by location. Another student, they just look at 3 countries, look at doing some emotion analysis. Because in the tweets, we can use that emotion analysis to say, from this tweet, are people happy, angry, sad? And then we wanted to see whether there's any difference across the country. So again, my future plan, what I wanted to say is I wanted to like learn how I can incorporate more advanced content. And now in the Databricks can also do the graph analytics and deep learning, which I have not investigated, I plan to do. And the Spark SQL, I think it's the Databricks Community Edition is a pretty cool platform. Student, we can even in the database, student can learn the SQL using like Databricks Community Edition, and then with a huge data set, how I can optimize like storage access. And now the Databricks, they have a different format, how you store the data. The JSON is not most efficient, JSON file is not the most efficient one. Right now I store them in Parquet, because they're talking about the data table, which can like speed up the retrieval process. And then my plan is also try to identify all the big data set I can use, like I can utilize Databricks platform too. Okay, so this is my presentation, and welcome any question, comments you have.
So if it's okay, I just want to comment on how wonderful the last 2 speakers have been. Marlon did a great job of talking about the use of I don't want this to be a marketing sort of conversation about Databricks, but it was great to see the students when Marlon was talking about the students liking Databricks and it being useful for his instruction and also for them getting jobs. And then Suhong took it a level deeper down into the architecture, and that's one of the reasons these conversations are so important, because if you want to teach Community Edition with Databricks, then you can see that it's wonderful for students. It's low overhead. There's no credit card. They get to learn key concepts without getting too down into the details. But then that was great scaffolding for, now I have a couple of terabytes of data and a billion tweets, and we take the same platform, add some back-end infrastructure, and then we can run queries on counts on those records, and they'll execute in just about a minute. So to give you an idea of numbers, let's say there are 200 schools in the Databricks University Alliance. There are roughly 30 schools out of that 200 that have taught Community Edition and are now using Databricks Enterprise on top of AWS or Azure. Most of it's on AWS right now, and doing the type of work that Suhong is doing. So For those in the audience who are interested, I know Terry out of Ireland will have a conversation, I think, tomorrow about this. It's a great segue because you can teach the basics and get those students scaffolded. And then if you want to go deeper, then it's not too big a step to go to the next step because when your data doesn't fit on a laptop, then you need a solution that doesn't require a PhD in Hadoop. So that was a joke. Sorry, it was a bad joke. Anyway, so yeah, if there's any questions, I think we're looking at LinkedIn and here. But thank you so much, both Suhong and Marlon, and we'll set it up now for Jay.
All right, thank you, Rob. Can you see my screen?
Not yet, Jay. So press the share screen button.
My bad.
There we go. Okay, looks good.
All right. Good morning and good afternoon, everyone. Thank you very much for attending this seminar. And I'm also honored to be invited to present our big data teaching practice in our school. My name is Jay Shan. I'm assistant professor from Miami University, Farmer School of Business, Department of Information System and Analytics. So in our program, we have been teaching big data and AI recently for several years. So here, I'd like to share some of our teaching practice. We want to contribute from a business school perspective, and hopefully it can invoke some interesting discussion and conversation. A little bit introduction about my institution. So this is Miami University, not in Florida. We are in Ohio. We are located in a small college town called Oxford, not the one in England. We are one of these regional public Ivy schools. Also on the list are University of Virginia, University of Michigan, UC Berkeley, and William Mary. So it just highlight the quality of our education and the teaching. We are currently listed on the top 50 national public university and top 10 in commitment to undergraduate teaching. So traditionally, our university focus on undergraduate teaching. And now we are also creating more graduate level programs, especially in our division, Farmer School of Business. So Farmer School of Business is ranked as the #1 public business school in Ohio, and we are proud to be the #3 for producing the most Fortune 500 CEOs. So entrepreneurship is something we are emphasize a lot in our curriculum, and we just created the department and major in recent years. So another special focus is we focus on experiential learning. So we have lots of curriculum elements is focused on let students to practice to apply their learned knowledge into practice. So this actually defines the tones of our big data curriculum too. So from last year, we start to offer the Master of Science of Business Analytics. We are kind of like a catch up and try to offer these new programs, not only for the broad interest in the business analytics, but also focus on our on-campus students, not in the business school, but from other departments. They want to learn something more about business, about analytics in the business context, and this program is designed for them. Okay, so in terms of learning objectives, I think our previous two great speakers already shared a lot. There is a very similar structures. We focus on the data management and collection. We talk about how can we apply different analytics methods, such as descriptive, predictive, prescriptive method in the different business problem. And most importantly, also focus on communication, such as visualization, how to write business summaries, and how to communicate with different stakeholders. Based on our past years, we have, based on the data from the past years, we have 100% job offers within 1 month of graduation. Actually, most of the candidates, most of graduates have multiple job offers. So for them, it's tough to make a selection sometimes, make a decision sometimes. And the average salary is around 70K. So that's really a very amazing achievement for a new program like ours. And one thing personally I'm especially proud of is we actually make this program purely in-person experience for the past academic year. What I'm trying to say is all the faculties teaching the related courses are willing to teach in class. And of course, at the same time, we offer online options, which means a student have the freedom to choose either come to the classroom or they can stay online. So we offer them this flexibility. And of course, within the classroom settings, we keep social distance, and also our division did a great job to maintain the cleaning, do all the cleaning work for our classroom. So in the past years, we succeeded, and we are seeing lots of benefit from this one, especially for a small program like ours. We see that there's lots of value for in-person teaching. Oh, so here is a design for our big data and AI curriculum. Currently in our master program, we have 2 courses in the sequence. So we have ISA 514. It's co-listed with 414, which means we offer this course not only for our MSBA students, also for our senior and junior undergraduate students. So we start with a big data, then moving to the scalable machine learning, and then we go to the modern AI. For us, the way we define modern AI means that we are focused on those data-driven and analytic-focused AI technology for enterprises, especially because we are teaching this in a business school, right? So in the first course, we introduce the concept and knowledge about big data and focus on the data collection, especially talk about how can we collect unstructured data from Twitter and other social network platforms and do the text mining on that. And then we switch to the distributed storage and processing. We start with Hadoop, talk about what is MapReduce, a concept, although we stop really as students to really do the programming MapReduce anymore. And then we switch to the Spark side, especially we try to compare the difference between the Hadoop system and also Spark system. So Spark is part of Hadoop for sure, but now we are also seeing that Spark is shifting from this MapReduce paradigm for sure, right? And in the second course, because we laid down a very solid foundation in our first course, the second one gave us opportunity to dig much deeper. So we try to cover the key concept in distributed computing in Spark. For instance, we talk about the setting the Spark call and talk about what is a driver, what is a task, what is slot, all those fundamentals. So we see this as a essential component to really let the student understand, what is a computing paradigm behind all those fancy interface, right? So we don't want students to use it as a black box. We want them to understand the mechanism. So actually, many thanks to the Spark community, Databricks Community Edition, it offers us a beautiful interface to dig into all those details. So after we execute any small activity, we can see the result. We can do very easy visualization, but most important, it also have lots of details for the internal mechanism. We can see that how much resources use the different stack and how many stages we have for each different each different task. And all this information offer me, the instructor, the flexibility to decide whether we just cover some, conceptual knowledge, or we can get into some technical details, many things. And then we, using this solid foundation, we move into the scalable machine learning, or you can call it machine learning at scale, which means we can use multiple nodes to train either one single algorithms, or we can do the hyperparameter tuning using multiple nodes in a big environment. And then we use a recommendation system, especially the collaborative filtering algorithm, LS, which is a very beautiful case. It's designed by the Databricks, by the way. Thank you again. And so let them to understand to handle a big scale problem like Amazon reviews. That's impossible to load all the data and execute all the analysis within a single machine. Of course, if you have a single powerful, very powerful server, that's not a problem, right? But the reality is most people don't have this resources at all. So using the Databricks, it gives us opportunity to let our students understand why it's so critical. We need this distributed platform to make interesting business problem to have, right? To solve the interesting business problem. And then towards the second half of this course, we switched to more AWS platform. So we talk about, voice recognition, image analytics, video analytics, those kind of topic. Currently, this part is purely running on the AWS, they call it AI as services. Those applications, and it's a beautiful combination with the Databricks platform because Databricks is running on the AWS anyway, right? So personally, I'm looking for something which can, make those two parts integrate all together, and rather help me a lot in this dimension. All right, so after introducing the program, let me introduce a little bit by myself, why I'm teaching this course, why I'm interested in teaching course, why I'm so devoted to, to teach this area. First of all, I have background in computer science, and for the PhD program, I graduated in Penn State Small Business College, and with business administration and also operations research. And I also have a minor in statistics. So before joining the Miami University, I was the University of Cincinnati Manhattan College. One's private, and the other is public school too. So East Coast and Middle West, it gave me the exposure and also experience to teach different sides of the classroom and different group of people. And for the teaching experience in the past 10 years, more than 10 years, I covered basically the whole spectrum for the data-related courses. It started with the database management, goes to the data warehousing and traditional business intelligence, and then moving to the machine learning side. And then based on that, I started to teach big data management and artificial intelligence course from 5 years ago. So my journey is pretty long in the big data area. So I just want to show you this snapshot. So what I did in the past 6 years. So I started using about 2015. I started to build my very first Hadoop cluster in my office. I know it was a crazy idea, but I enjoyed it a lot. I built student teams and work with them to put everything together. At that time, the claim of the big data was that we can leverage our existing resources to leverage all those retired machines. Of course, for some of the name nodes or job trackers, we need advanced computer, but overall we can use the existing resources, and it was a success. We start to launch our big data courses a long time ago. Then later on, we switched to more in the cloud space. So we use AWS EC2 to build a small scale cluster using the Cloudera's offering. So by the way, this picture in the upper right corner is borrowed from Cloudera. Sorry, I should put on the logo for them. And sorry, let me check. Yeah, you're right. That's a major complaint from my neighbor. She told me that the temperature was increased and all the also maybe some radiation too. But we survived those years. And then we also tried the EMR, on the AWS. We tried all those options, and those experiences definitely help us to understand the whole ecosystem, and also, oops, sorry, for whatever reason, I took myself off. Sorry about that. And then recently we start to use the Databricks, and I totally agree with Soo-Hong. It's a big game changer. It's make our life so easier to handle such big platform. I'm not saying the previous experience do not help. They do, but at the same time, I want to tell the newcomers, it's really a big fortune for us to have this platform at hand. It's very convenient and can save us quite some effort. That's the truth. So we have a quite hands-on learning design. We should look at this picture. This is spiral from the bottom. So after do the big data overview. We start with some Python basics. Oh, by the way, this course was designed for both undergraduate and graduate. For the graduate version, we can skip some of those Python components because they already learned from the others. But for our undergraduate version, we basically opened the doors to a broader audience. So when they came to this course, some of them don't have the Python experience at all. So that's the reason why we try to do the scaffolding. Just like Rob said, we need to place in all those little cornerstones before they can really feel comfortable to handle the big data problem. Then we move up to, how can we do the data frames in the pandas. Then we talk about how can we use web API to connect, different data sources and collect unstructured or semi-structured data in JSON or other different platform. And then we go to natural language technical kit, NLTK, to teach fundamental text mining. So those are basically let the students to understand how those unstructured data can help, right? So if they don't have the basic knowledge of the machine learning, they cannot see why we are handling those unstructured data. So by doing sentiment analysis, generate the sentiment score, we help them to realize that all those structured data can strengthen their current machine learning classification model, clustering model, whatever. And so that is a part which can link to their other courses, right? So other learning components. Then after that, we start to justify that why we need a big system. Just because when we start to pick up and more big volume of the data, the current system cannot handle using one single node or one single machine. So that's why big data distributed system becomes necessary. So we talk about HDFS and MapReduce. We talk about how can we do the easy data integration or ETL using the Scoop and Hive. And finally, we get into the Spark SQL, ML, and ML-Lib. The point is we want to show them all their knowledge learning from the database course, all their learning from regression course or machine learning course can be easily transferred into this big data platform. And all those functions, all those SQL commands are so similar, they don't need to relearn it at all. They just need to practice it, know the difference, and that's it. Okay. So that's something we feel that is really helpful to link other knowledge they learn in this program and towards our big data platform. In the interest of time, let me skip the details for those advanced topic and jump into our exponential learning components. So in our program, we have a dedicated course, ISA 650, talk about practice. So in this course, we connected with industry partners. They share with us a real data set with a real problem. And different teams are working on the same case, basically the same case. It's a semester-long effort, so students can keep communicating with a different stakeholder, talk to the company, and finally deliver the final product to them. It's amazing experiences. And the big data platform offers additional tools. We don't fix the tools. They can choose whatever tool they want. And Databricks definitely is a big player in this family. And within the courses I taught, we also emphasize group project. I give the student the freedom to choose the topic they want to work on. They need to collect their own data, build their own solution, everything is on. And we also encourage the sharing between the different teams. For us, is very important because big data, for most of them, are so new, they need to learn from each other and also offer the critics to the other teams. And this has been a very successful experience in our big data curriculum. And most important, this is success not limited within the course. Some of the team, they send this class project into international analytic competition and they win award. For instance, in the last year, our team wins this Teradata Analytic Challenge 2020 overall winner. And they also carry this knowledge into their research. Miami University is put lots of resources in undergraduate research. So our undergraduate students have the opportunity to lead a different project, present their findings. And so they also use learn in the big data platform to put into the action and do something interesting to them, And I'm just sitting on the sideline to be a cheerleader and to share the resources with them. And this project is very similar to Professor Lee just shared, so I will not repeat this again. All right, so, sorry, I used too much time, guys. So here's the lessons I learned from this long journey. So persistent learning is something must. We know that this area is so moving so fast. It's so important to have a community like ours, right? So I want to extend this thanks again to Databricks to create this community. So it make us so easy to share our resources, share our learning, and most important, support each other. I don't even want to mention that how quickly Rob is supporting us in each different dimension, right? And the second part we saw that is, the curriculum design is really a big challenge. So for instance, here, you can see that I cover lots of different topics. Sometimes it becomes a problem because we don't have enough time to get into the depths of a single topic. So my personal recommendation is choose your bucket. You have bucket, you can choose what you want to put in. Don't worry about the broad spectrum. That's too many new topics, many things are going on. It's no way we can cover it. So that's why, you just need to focus on what you are really interested with. And I think that the concept, the big picture, the paradigm is the most important knowledge to deliver. And of course, for the business school, the challenge is how can we make this more towards the case study format? We know that, most of the beneficial components in the business school education is about case study, classroom discussion. And we are also working on that. And hopefully we can have some new experience to share with us and discuss in the near future. And another big change is going on is data infrastructure and data governance. I think Databricks also putting more and more resources in this dimension. And from our point of view, cybersecurity is not only about technology, it's more about data operations in the business practice. So we are creating a new cybersecurity management track in our undergraduate program. And we are trying to check how can we leverage this Databricks platform to, introduce more advanced concept in this domain and help to create some practice-based curriculum courses, in this area. That's it. Thank you so much. This is lightning talk. I want to say, Databricks, this alliance of lightening our, education effort. And then I hope this talk can be helpful to your current practice too. Thank you very much.
Oh, that was great, Jay. Sorry, Karen. I wasn't sure if you still had the background noise.
No, go ahead. Go ahead.
Okay. And again, I think the sequencing was perfect because what Jay was talking about is it's great to know the history, and that's why I love the picture of your desk so much. That was so like 2005 or 2006. As we evolve, what we're going to see in 3 years, we don't know. We know what we're working on now will evolve, but what we'll see in 3 years, we don't really know. So pick what you're interested, stay on top of that, and the ultimate benefit is really the students and the kind of jobs that they can get. And the other thing that Jay emphasized was looking at data science in the format of a case study. And there's a whole line of business, there's a whole organization within Databricks that talks about how we map the data science and analytics work that we're doing to business value. Because at the end of the day, if what we're doing is not driving innovation, driving shareholder value within a company, then Marlon could make the best model on the planet for a particular, particular learning algorithm. But if it's not mapping to business value, if he's not telling the story about its value, then we lose that, the scale of his impact. So great sequencing. I think so far we've answered all of the questions in LinkedIn, and it's been pretty quiet here on the Zoom channel. But my email address, rob.reed, rob.reed @databricks.com. Any questions, reach out about the program or the content. And this is, I think, our fourth lightning session. We usually have them every 6 months. And in my mind, they just keep getting better and better. So thank you for sharing and listening. And I'll let Karen wrap it up.
Yeah, thank you so much, Suhong, Jay, and Marlon. That was really great. I'm happy that we were able to run it as part of the meetup group and broadcast it live so we could share it with more people. So with that, thanks so much. Thanks everyone for watching. The recording is available on YouTube. So make sure to check that out if you'd like to revisit the session. So with that, I hope everyone has a great rest of your day. Take care.
Thank you, everyone.
Thank you.